In this video we're going to solve this physics problem. We have the motion of a particle described by Vy and x functions below. We're going to need to find Vy, Vx, Ax and Ay to find the magnitude of speed and acceleration. But first we'll solve the first part of the problem first by plotting y versus t. So we've been given the velocity in the y direction, but we don't know the y position function. So we need to integrate velocity to get the y position function, and we've got that there. So c is the constant of integration, but we're given a coordinate there, t equals 0, y equals 0. So we're going to use that to solve for c. So we set y equals 0 and t equals 0, and we'll find that c will equal 0. So there we go, c equals 0. So the y position function is -4t squared. So we can now plot this function, y versus t. In this particular case I've used Python to plot the function, and the code will be available in the comments section via a link to GitHub. So here is the code. We'll run this code, which will produce this plot. Now we need to work on the second part of the equation, or the question, finding the total speed and magnitude of acceleration. So we have the x position function there. To differentiate that, we get the velocity in the x direction. So d dt, 5 take away 2t squared. The 5 will go to 0, and the -2t squared will go to -4t. So velocity in the x direction is -4t. We can find the acceleration in the x direction, differentiate velocity to get acceleration. So differentiate that -4t, which is simply -4, which is a constant acceleration in the x direction. We still need to find the acceleration in the y direction, but here is, we can start writing the equation to find the magnitude of acceleration, a, which is the resultant of ax and ay. So a equals the square root of ax squared plus ay squared. We've been given the velocity in the y direction, so to find acceleration we differentiate velocity, that -8t, and so acceleration will be equal to -8. Once again, constant acceleration in the y direction. So the magnitude of the acceleration is the square root of -4 squared plus -8 squared, which is equal to 8.94 meters per second squared approximately. Now we've been given that time equals 2 seconds, and we have Vy is -8t. Vx, we've worked that one out too, which is -4t. So we can plug t equals 2 into those two equations and get the actual velocity at time equals 2 seconds. So -16 meters per second and -8 meters per second in the x direction. We can now find the magnitude of velocity, or the resultant velocity, combining Vy and Vx. So V equals the square root of Vx squared plus Vy squared, which equals -8 squared plus -16 squared. Which equals 17.88 meters per second approximately.